be helpful for me to cover more and more problems. Otherwise, in the place of 4 to 5 problems, I may do only 2 problems and one give it as an assignment, and also stuff happens. Okay, so make sure you calculate the things fast and give me the value so that you can solve more and more problems. So this is the thing which is given here. Okay. Fine. So let us write down the given data for this particular problem. Okay, the pair of helical gears. So the first, identify which type of gears is given. I was talking about this in the last problems also. So the given data, according to the given data, now it is a helical gear. Very good. The power transmitted is 15 kilowatts. I will just write that 15 kilowatts. The teeth are 20-degree stub. So 20-degree stub, he says. So just write 20-degree stub. It is not full depth, so it is 20-degree stub in diametrical plane, and have a helix angle of how much? So helix angle is being specified as 45 degrees. The pinion runs at 10,000 RPM. Look at the speed at which the helical gear can run. Okay, I would just write a wheel and a pinion. Okay. So this is one, which is pinion, and this is a gear, which is, I will take it as 2. Now, N1 is given as how much? 10,000 RPM. That's a huge speed. Okay, helical gears can run at very huge speeds. Not the spur gear. The spur gear will be having a little bit of sound. Sound in the sense when the gear rotates, no, you'll get the sound. Like that sound, you'll get it. But when you come for an helical gear, there is absolutely zero noise because of the gradual engagement of the teeth. You'll come to know about it. Okay. And has 80 mm pitch diameter. So I would write D1 as how much? 80 mm pitch circle diameter is being given. The gear has a pitch circle diameter of 320 mm. So D2 is 320 mm. So since D1 and D2 are given, we can calculate the value of I. Be ready with that. If gates are used of cast steel having an allowable stress of 100 megapascal, so this is made up of cast steel. Okay, and sigma D1, he has mentioned it as 100 megapascal. So gears in the sense both the things are made up of same material. Cast steel, and sigma D2 is even 100 megapascal. Okay. Next, check the gears for wear. So what you have to find as our design is you have to check the gear for wear. Okay. Face width and module. So for all these things, you have to check it. Given, even sigma ES here is given, so just write it down. Sigma ES is 618 megapascal. So anything which is given, which has been not been listed here, is everything been listed? Whatever the parameter is being given. Shall we start the problem? Okay. So what is our first step in a gear problem? I told you the procedure remains entirely the same. Nothing is going to change. Only the formulas where you take for a helical gear, only those things will change. Everything else will remain same. Okay. So it is a bonus. Like if you learn spur gear, it is a bonus that you'll get helical gear also. Okay. So that is why these gears are very easy. And now, what is our first step? What is our first step in a gear problems? What is our first step in our gear problems? Alphas? Alphas.
Yes, sir.
What is our first step in our gear problem? What do you have to do firstly before starting our design? Yes, Alphas. Don't waste our time. Please be fast.
Identify weaker.
So we need to find a weaker part. So we need to find a weaker part, and weaker part is being found using sigma d cross y, isn't it? Now, since both the materials, the gear as well as the pinion, is made up of the same material, we naturally come to a conclusion that the pinion would be a weaker one. Just write all these sentences. Okay. So since the number of teeths are not given, in the material, you have to assume the Z1 as 20 teeths. Okay, this is a standard value. So you have to take the Z1 as 20 teeths. So we have to start from that. Later on, we'll be checking whether the assumed value is right or wrong. Okay. So initially, you take Z1 as 20 teeths. Since the value of I is known to you, if it is not known, you can calculate from here. Okay, where I is equal to what? D2 by D1, that is 320 divided by 80. So it comes around 4. Okay, using that particular value, we can calculate the value of Z2 also, assuming the value of Z1. So whichever is a newer thing, I would be just writing it in a red color. Okay. And there is a concept called as, listen here. So here is a concept called as virtual number of teeth. So you have to calculate. For that, all of you go for equation number 12.22a, page number 211. So just go for page number 211 there. Look there what we have there. So this is the virtual number of teeth or equivalent spur gear teeth, formative number of teeth, all resembles the same value. One is virtual number of teeth you can call, or you can call it as equivalent spur gear number of teeth, or you can call as formative number of teeth. Even you have a small bit of derivation for this, which is being asked almost all 5 to 6 times in the last 5 question papers, 5 years question papers I've seen. So it has been asked for 6 marks or 4 marks, like that. It is a small derivation. You can just we will take up once we have done with the problems. Okay, so take this, ZE is equals to Z divided by cos cube beta. So it is taken from equation number 12.22a, page number 211. With that particular equation, calculate the value of ZE. Okay, ZE1. So how much is the value? So this is what? I can just set Z1 is 20 teeths, which we have assumed. Cos cube of beta is 45, which is given in the problem. So how much is the value?
$56.56.
How much? 56 point? Yes, Alphas? 56. Okay. So just take it as 57. Go for the next higher value, because teeth cannot be half, no? Just go for 57 teeth. Okay. Once you calculate that, next go for the module calculation. For the module calculation, just go to your data handbook where it talks about the helical gas. So from page number 211, he talks about the helical gas. So whatever the formula you find here, only these formulas has to be used whenever there is a problem given on helical gears. Mind that, okay? So in this particular part of your data handbook, take the expression for your module. So where you can find in page number 214, equation number 12.24b, which is this particular equation. So here it is not just m to the suffix n. We'll call it as a module normal or a normal module. Okay. So you have all the parameters which need to be calculated here. Sigma D is your allowable stress. CW is your wear and lubrication factor. We will see from where you can get this. Table number 12.21. We'll just look at it. Capital Y is pi times the Y. Y is Lewis form factor. So table number 12.5 you can take, or else you have an equation for that. We shall see it. K is B by M, which is nothing but a width to module ratio. Case width to module ratio. Okay, let us go one by one now. So in order to calculate the value of CV, so first you need to calculate the value of V, isn't it? So pi D1 value is how much? Directly substitute in meters, guys. So it is 0.08, 80 mm was there. Next, N1 is 10,000. Since I am taking all the parameters of gear or pinion, whether I should take the parameters of gear or a pinion. Pinion, isn't it? So just substitute all the parameters of the pinion. That's why I have mentioned here as 1. Okay. Now calculate V. On the basis of V, you can calculate the value of C. What is the value of V? What is the value of V?
41.88.
41 something, right?
41.88.
Okay. For this particular value, go for the data handbook. Go for the data handbook and gets the Bart's formula for calculating CV for the helical gears. Do not look for the other gears. Just go for the helical gears. Do not take the formula for the spur gear. Whenever there is a problem for helical, you have to go for helical. Whenever there is a problem for spur, then you have to go for spur. Do not intermix that. Okay. So for precision gears with V greater than 20 meters per second, now it is 41 point something, isn't it? So it is greater than 20. Pick up this particular formula. Okay. V here is 41.88. Now, what is the value of CV, guys?
Zero 0.46.
0.46. Okay. Now, calculating FT remains the same. You have this particular FT expression in your data handbook. Same expression you can take. Okay. What is the power given? Power is 15 kilowatts. So power is 15 kilowatts. Speed you have just calculated, isn't it? It is 41.89 cross CS. What is CS? It's a service factor. Now go for table number 12.8 to get that value. 12.8 to 35. 12.8 to 35. So always okay. Now always select the value of 1 whenever there is nothing given in the problem. So this you take it as a standard or a thumb rule. Whenever there is nothing given, whether it is intermittent, whether it is continuous operation or 8 to 10 hours, steady, medium, heavy, nothing is given. Just take it as steady shocks with 8 to 10 hours per day operation. So you will get the value of CS as 1. So the same thing I have picked that. I have taken the value of CS as 1 there. Okay. Next, I will just write it here. Give me the value of FT then. You know where this particular equation is being taken? It's a common equation between helical and spur gear. Okay. I'm just searching that particular equation number. If anyone finds it, just give me that so that it would be easy for me.
358.08.
How much? 358. You take a whole number. Okay, 58 newtons. Now, next go for calculation of capital Y, which is a form factor. You need the value of Y of opinion, which is 1. Okay. Now, go for page number 204, which is this. Okay. For 20-degree stub system, pick up the value. Okay. 20-degree stub system, pick the value. Pick the equation, write it here. ZE1. Okay. So you can just, you have to write it as ZE1 there. Because it is an equivalent number of teeth on the spur gear. So this is important. So what I will do is, I will just highlight this. Oh shit. So you're converting it into a spur gear and then you are finding out the value of form factor. ZE1 it is. So initially you have find out the value of ZE1 as 5.7. So just substitute everything and get me the value of form factor. So if you have any doubts in between, immediately raise it up. Okay. What is the value of Y? Capital Y, form factor.
0.026.
0.021. Okay. Is it correct? Let's check particular value. Is the value correct? Why? Yes or no?
Yes.
So what you have substituted, but the textbook value was a little bit different. I don't have the calculators either. That's the correct value. 0.49 is the correct value. So why there is a difference again? Why there is a difference in the value?
ZD is
Sir,
57.
ZD is 57, not 5.7.
Correct. ಇದು 57, 5.7 ಅಂತ ಬರ್ತಿದ್ದಲ್ಲ. Now what is the correct value then? 0.49. Can I take that? Everyone is getting the same value? 497. If you are getting the same value, just raise your hands. Okay, good. Nice. Okay, now, so since the value of K is not given, you have to assume it as 15. Okay, in case of a helical gas. So how much you used to assume if it was not given in case of a spur gas? I mean to say, in case of a spur gas, if it was not given, how much you used to assume previously? 10, isn't it? Now, in case of a helical gas, you assume it as 15. Okay, that's why I have it in the red color. Okay, that's nice. Now, even you have to assume the value of CW, which is 1.15. Go for table number 12.21, page 241. You get to know what is that particular thing. It is known as a wear factor. 12.21, page number 241. Page number. No. Yes, this one. Okay, nature of lubrication. If the gear is totally closed, okay, and continuous oil supply is there, then you can take the wear factor to be 1.15. There is a limited amount of lubrication, but frequent inspection is there. That means in the day 2 times, if you lubricate it, then you can go with 1.25. For any other different lubrication condition, that means lubrication is worse, then you can go for 1.35. Naturally, we would take it as 1.15. Okay, if nothing is given in the problem, nothing specific is given in the problem, what you have to do is you have to take with 1.15, which I have just written there. So same thing you can write, assume CW is equals to 1.15 in the table number 12.21 at the page number 241. Okay, now calculate the normal module since everything is known now. Okay, what is the normal module? .09. Very good. So 1.09. So take this particular value, go for the table number 12.2 in the page number 229 and give me the standardized value of that. Give me the standard value from the tables. Same table you can use, which you have used for the spur gap, because it is a normal module. Sumant. So 1.25. Very good. So once we have calculated 1.5 or 1.25. Why there is a confusion again in picking up the module? What was the page number to select it? 229. You have 1.25, no? You can take it 1.2. Why are you taking 1.5 unnecessarily? you have an option of 1.25, which is preferred in the first column itself, then what is making you to think to take the value of 1.5? Rutvik, Mithun? Why are you taking 1.5? Rutvik. Rutvik.
Yes, sir.
Why are you taking 1.25 when 1.25 is available?
Little nearer.
Little nearer. What the value we have got? 1.09. No?
1.25.
Okay, first we'll take for 1.25. We'll check for the sigma ID. Then if it comes lower than the 100 megapascal, then it is fine. If it does not come below 100 megapascal, then we can increase to 1.5. Is that fine? Everyone, Mithun, Rutvik, Suhas, Raven. So first we will check for 1.25 because it is a preferred value and it is in the first column. Okay. Just check for 1.25 now. 1.25. Have to check. Before to that, calculate the number of teeth on the pinion because you have assumed initially, no? So we had assumed initially. For that, you can take the equation number 12.19d from page number 211, where it says Z1 is equals to, there it is given only with respect to a common thing. Z is equals to d into cos beta divided by mn. But here you can just apply it for the pinion. Z1 is equals to d1 cos beta divided by mn. So m1, you have just calculated it as 1.25. Just substitute it and give me the number of teeth here on the pinion. Give the number of teeth on the pinion. 45. Okay. Is that exactly 45, Arif? Ah, 45.25. 45.25 in the sense you have to go for next value. What is that? 46. Now, multiply it with the velocity ratio and give me the number of teeth on the gap. 4 4s are 16, no? 4 6, so 184. Right? So immediately, once you calculate the number of teeth on the pinion and gap, immediately what you have to do is calculate the equivalent number of teeth on the pinion and gap. Equivalent number of teeth is given by equation number 12.22a, page number 211. So here you have, so Z1 you have calculated it as 46 teeth. Cos cube of beta is 45. So what is the equivalent number of teeth here? ZE1. Virtual number of teeth or equivalent number of teeth or formative number of teeth, everything remains same. All has the same meaning. What is the value? ZE1. Yes, given the value of ZE1, 130.1. Okay. So this is a whole, do not convert it to whole number, just keep it as such, 130.10. Same thing you substitute here, 4 times I is 4, no? 4 times of 130.10. Do not convert into a whole number because it is a virtual number of teeth. It's a value, but it's not the whole number. It's just a value, virtual number of teeth. So 413. Okay. So 520.4. So calculate this and keep it as it is. Now face width. So face width is 15 times the normal module, because B by Mn, we have assumed it as 15 there. So 15 into 1.25, that is 19. So 18.75 you would get. So approximately I have round it up to 19 mm. So once you have calculated the face width, so since face width plays a very important role in case of since face width plays a very important role in case of helical gears, what you have to do, you have to check whether the face width which I have calculated, which is 19 mm, whether it is safe or not. Whether it is safe or not, that you have to check. So how do you check for safeness of your value is? Just go for equation number 12.23b, page number 213. Where is that? Page number 213. Okay. Just go for this minimum face width formula. Equation number 12.23b. So this particular equation. Okay. According to AGMA, the minimum face width should be, he has given, see, the minimum face width should be this much. You can take that particular formula, which says it is 1.15 m. Okay, 1.15 pi into mn divided by sine of beta. Now, from this particular equation, just substitute, so it is 1.25 Allah. 1.25 Allah. There is a power loss. Just calculate the minimum face width that has to be there. B minimum. So according to the formula, you have the minimum face width as 6.38 should be the minimum face width, but your face width which you have calculated is 19 mm. It is way above, so it is way more safe. Okay, so how to check? So once you calculate the face width, you have to use this particular sort of equations here, minimum face width equation from here. So there you have to calculate the value of the minimum face width, and whatever the calculated value was there, the designed value was there, the value which is designed by you should be very much greater than the minimum face width. When it is greater, then you can just add a sentence here, since B is greater than B minimum, the calculated value of B is safe. Calculated value of B is safe. Okay. Now, once you have done that, go for checking sigma D2. Go for equation number 12.2 for the A214. Where is that? Here, the Lewis equation. Pick this particular equation here. Okay, 12.24. In that equation, start calculating one by one. First, go with the calculation of y. It is pi times of, since it is based on opinion. So you have ZE1. So always remember, I will just write here. You have to substitute here the value of ZE1. I am highlighting it with the red color. So if you substitute Z1, you'll get the wrong answers. You have to always substitute the virtual number of teeth. Okay, 130.10 was the virtual number of teeth. So give me the value of capital Y, the Lewis form factor for this. Since all the other values are being already calculated, okay, already there with you. Only Lewis form factor has to be calculated. ಹೌದಾ? ಸರಿ ಸರಿ ಸರಿ, ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಇದ್ದೀನಿ. ಓಕೆನಾ, ಮಾಡ್ತೀನಿ. Okay, what is the value? 0.5. 0.5. 26. Okay, just substitute the value and whether check it is less than 100 megapascals or not, which is the level stress value. Just calculate the value of sigma d1. Check whether the calculated value is less than 100 megapascals or not. .39. 71.39. Now it is less than 100 megapascal. So you can just write this particular equation there. Since the calculated values are less than the permissible values, hence the values are satisfactory. See, if you unnecessarily increase it to 1.5, it would be waste of money for us, isn't it? So 1.25 you have to check. If it is not satisfactory, then you have to increase it for 1.5. Nor simply you should not go for a higher value. It has to be some justification why you have gone to that higher value. Okay. Very good, very good, very good, Amir. Okay. Any doubts until now? All the procedure remains same. Just there is a small change. See, initially you used to substitute just Z1. Now we have substituting ZE1. That's it. Okay. Little bit changes would be there, but spur and helical gas. Okay. Now once that is done, just calculate. Phase width is already calculated since he has asked. So you have fixed upon the module now. So module is being fixed as 1.25. That is what we are checking for. So first we have checked the phase width as 19 mm. So just mention B. Your calculated phase width is 19 mm. Just show them. Next thing you have to check for dynamic and the wear loads. So calculate the dynamic load. For dynamic load, you have a separate equation for an helical gas, which is given by equation number 12.26 at the page number 214. Write that big hell equation onto your book. Everything remains same. Substitute, calculate, and give me the value of dynamic load. All the things remain same. FT you've already calculated, I guess. Right? FT you've already calculated. K3 you have in the data handbook itself, he'll be mentioning there. Here it is. According to the Buckingham, the dynamic load on this one is given as so and so. So K3 is already given. Okay, always take it in SI units, 20.67, which used to follow in the previous problems also. Same thing. C, again, dynamic load factor, same procedure you need to follow to calculate your value of C. Okay, first go for here. Okay, now for what is our velocity? I think it is something above 40, isn't it? 41 or 42 something. Yes or no? So if it is above, you can, the last possible error that you can get is 0.127. So you have to take that particular value of itself, 0.127, and come back here. So 0.127 now. Oh, 0.0127. Okay. So 0.0127. So minimum value you have it as 0.01 here. Okay. For steel and steel combo, just take the value of steel and steel on 20-degree stub bala. So for 20-degree stub is this. For 20-degree stub is this. For, and the value is this particular thing here. So just take that value. So you have two different, you can go with this particular method here. Okay. For alpha is equal to 20 degrees stub. Okay. Steel and steel combo. At error is equal to 0.01. You have C value to be 118.7. Just follow this particular method here. At error equal to 0.01, at error equal to 0.01, the value of C is 118.7. At error equal to 0. ಆಯ್ತೇನಪ್ಪ ನಿಂದು ಅದನ್ನ ಓಡಿಸೋಣಂದ್ರೆ At error equal to 0.01, you have the value of C is equal to 118.7. At error equal to 0.0127, what is the value of C? So in such situations, what you have to do, you have to just cross multiply the things. Okay. When you cross multiply, it is 0.0127 into 118, which is this. C, the value to be calculated into 0.01. So C is equals to 118 into 0.0127 divided by, when you transfer the value to the other side, it would come to the denominator. What is the value of C you will get? What is the value of C? Oh. 150.7. That's the right value. So 150.7. So once C value is calculated, substitute the full length equation in there. Substitute all the things and give me the value of dynamic load. Megha.
Yes, sir.
C value correct bandide na 150.75. Okay. Calculate the value of dynamic load. Dynamic load ಮಾಡಿ ಹೇಳು ನನಗೆ ಬೇಗ ಎಷ್ಟು ಬಂದಿದೆ ಅಂತ. ಶ್ರೀನಿಧಿ.
ಹಾ ಸರ್.
ಪೇಪರ್ ತೋರಿಸು, ನೀನು ಎಷ್ಟೆಷ್ಟು ಮಾಡಿದ್ಯಾ ನೋಡುವ. ಕ್ಯಾಮೆರಾ ಆನ್ ಮಾಡು. ನಿಂಗೆ ಹೇಳ್ತಾ ಇರೋದು ಶ್ರೀನಿಧಿ.
ಹಲೋ. ಹಲೋ ಸರ್.
ಹಾ ಹೇಳಪ್ಪ.
ಇಲ್ಲ ಸರ್, ಇನ್ನು ಏನು ಬರ್ದಿಲ್ಲ.
ಏನ್ ಬರ್ದಿದೆ ಅಷ್ಟು ಮಾತ್ರ ತೋರ್ಸು. ಒಳಗ್ ಬನ್ನಿ. ಎಫ್ ಡಿ ವ್ಯಾಲ್ಯೂ ಬಂತ ಯಾರಿಗಾದ್ರು? ಗಗನ್
ಎಸ್ ಸರ್.
ನಿನ್ನ ಬುಕ್ ತೋರಿಸ್ ನನಗೆ. ಎಷ್ಟು ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಿದ್ದೆ ನೋಡ್ಬೇಕು ನಾನು. ಗಗನ್.
ಹಾ ಸರ್, 1 minute.
How much is the value of FD? 10.8 kilonewton. Okay, I will take that value. It is 10.8 kilonewton. Just check the value whether it is right. Everyone is getting the same value, because in the notes whatever I have, it's a different value. Just check the value. And parallelly, you just mark your attendance in the Google Sheet. It's already 2 minutes remaining, so just make sure you mark it. 1.56 kilonewton, na? Okay. That is correct value. 1.56 kilonewtons. So just check. Okay. So in the next class, by the next class, all of you have to check for the wear load, which is given by the equation. Just take the equation number 12.26c, page number 214. So there you'll be having the value of sigma ES there. Sigma ES is being given in the problem. So since sigma ES is given in the problem, you have to take the value. You have to calculate the value from the formula. Do not use the table for that. Okay. So calculate the value of wear load by the next class. Is that fine?
Yes, sir.
Now all of you just mark your attendance and leave. Okay, we'll meet up in the tomorrow's class.
Synchronization error ಬರ್ತಾ ಉಂಟು ಸರ್.
ಸರ್ ಸಿಂಕ್ರನೈಸ್ ಎರರ್ ಸರ್.
ಎರರ್ ಬರ್ತಾ ಉಂಟು ಸರ್.
ನಿಮ್ಮಿಬ್ಬರಿಗೆ ಏನಕ್ಕೆ ಬರುತ್ತೆ ಯಾವಾಗಲೂ ಸಿಂಕ್ರನೈಸೇಷನ್ ಏನಾಗ?
ಗೊತ್ತಿಲ್ಲ ಸರ್.
ಸರ್ ನನ್ಗೂ ಇದೆ ಸರ್.